Since 2022, Google engineers, in collaboration with the OSS community, have been building Kueue, cloud-native queuing system for AI workloads. My name is Patryk Bundyra. I'm one of the Google engineers working on that, and let me tell you a little bit about this very cool piece of software. Imagine you wanted to enter the place, accidentally called Kubernetes cluster. There's a line of people, and a bouncer decides who can enter and who has to wait. Kueue acts like this bouncer, deciding which job or pod can enter the cluster, and obviously, as the name suggests, it also queues them. Kueue works with various job types, such as batch job, Kubeflow job, RAID job, pods, and more. It abstracts them with an umbrella CRD called workload. Let's circle back to the line. Often when people wait in line, they can tell how many people are in front of them. Unfortunately, with Kueue and workloads, it wasn't that easy, and we have to give it a thought on how to expose that information to a user. One of the first ideas that can come to mind is to extend the workload object with its position. Simply, every time something changes in the queue, for example, workloads gets admitted, we would update the positions. While it may work on a small scale, could this work on a large scale? Let's say tens of thousands of workloads. Could the API server or etcd handle so many updates? Well, the short answer is not really. At some point, the API server would struggle to keep up with the pace. So we need to come up with something different. Maybe we could have a completely separate CRD that stores the order of the queue. It's almost as if our bouncer had a list with the order of the guests. This way, on every change, we would only need to update a single object in etcd. Mark it on the list and it's done. Sounds lovely because we only have to update a single object and we don't have to worry about QPS. But could this work? Well, certainly, but there's only so much we can store in a single etcd object. It has a size limit, so we wouldn't be able to fit all the guests here. Okay, let's take a step back and think about how CRDs work. When a user wants to make any action, they create a request that goes to the API server and then to etcd. However, besides CRDs, there's also another way of extending the Kubernetes API called Kubernetes API Aggregation Layer. It comes in very handy when we need to deal with a lot of changes, and etcd may not be the most suitable storage for that. With API Aggregation Layer, we can replace the etcd with different storage. It may be a banana, it may be a washing machine. If it implements the proper interface, then why not? Or, like in our case, it may be Kueue. We know the order of workloads in Kueue, so why not use that information? This is what we did, and indeed, it solved our puzzle. What happens underneath is Kueue stores all the workloads in heap structure. It doesn't assign particular position for every workload, but we always know what's the head of the heap, so we know who's first. Then, Kueue takes a snapshot of this heap. So it's not only a bouncer, but also paparazzi, as it seems. It converts the snapshot into a list of workloads with appropriate positions assigned. Last important thing is that we want to be really lazy about it. Kueue doesn't do that unless user asks about it. That way, we can ensure it's highly performant. Let's now compare these two ways of extending Kubernetes API. CRDs store the state of the object in etcd. Hence, they are very easy to set up, but also they come with some limitation and maybe not as performant in our cases like ours. They are used extensively across the whole Kubernetes ecosystem. Service monitor, job set, network policy, just to name a few. Aggregation Layer, on the other hand, uses its own storage solution. Because of that, it comes with a bigger overhead as it's harder to set up and requires some additional coding. However, in cases like ours, or for example, when you need to periodically collect metrics, it can be much more performant. It's also less popular than CRDs, and it might be harder to find somebody with similar issues like yours. As almost always, choosing the right tool is an act of balance. In this case, it's a balance between performance and ease of use. In Q, we want to use both of those, best of those both worlds. So the vast majority of our logic relies on CRDs. But when it comes to positioning workloads, we leverage API Aggregation Layer. Choose your tooling wisely, and thank you for having me.